Hello and welcome to Math with Lou. Today we are going to be taking a look at the distributive property. What does it mean to distribute something? You know, we're going to dive into all that fun stuff today. So here in my notes, I want to start out with an example to conceptualize what it means to distribute something through a geometric lens. Using geometry sometimes makes life easier in visualizing what we're talking about. So in this starter example, Henry here has two rectangles with the same height, and he wants to know the total area of these two rectangles. So here we have an illustration. Both rectangle A and B have a height of 2, and rectangle A has a width of 4, while rectangle B has a width of 7. So we're going to calculate these two different ways just to show that we can, and these will make a little bit more sense with some more explanation. But the first way we're going to calculate these is a way that we should all be familiar with, and we're just going to figure out the areas of these two rectangles and add them up. So rectangle A has a width of 4, or a width of 4, and we're going to call this height of 2. So the area of a rectangle is width times height. 2 times 4, 8. Rectangle B has a width of 7 and a height of 2. The area of this is 2 times 7, for an area of 14. So we know that the area of these two rectangles is A plus B, 8 plus 14, an area of 22. So now we're going to demonstrate this using distribution, and if we get an area of 22, we know our work is right. So let's talk about the distributive method to figure out the height. So for this, I want to imagine putting the two rectangles next to each other. So see here, they're connected. They both still have a height of 2. One has a width of 4, and the other's a width of 7. So the one way we can calculate these is we can add these widths together here, the 4 plus 7, and then multiply that by the height. So 2 times these widths added up, 4 plus 7, equals 2 times 4 plus 7 is 11. 2 times 11 equals a area of 22. So again, we're getting our 22 number. It's checking out. Or, now this is what it looks like to distribute. So here, I have the same thing as here written out, 2 times the quantity of 4 plus 7. But instead of adding up these two numbers, what we can actually do is distribute the 2 into the numbers, multiply those terms together, then add, and then get our final answer. So we can see that here, I distribute the 2 into the 4 and into the 7. So now it's 2 times this 4. The plus gets transferred over, and then 2 times this 7 here. 2 times 4 is 8. 2 times 7 is 14. 8 plus 14, 22. We still get our same area of 22. Now, if you're not experienced in algebra, you might be looking at this and saying, like, wait a minute, why would I even want to do that? This is so much more work than I need to. And this is actually so useful. Whenever we deal with unknown variables and we need to simplify expressions, we can use distributing techniques just like these to, again, make our life easy. And that's what we're going to look at next. So here is a good formal definition of the distributive property. So I wrote here A times the quantity of B plus C. Well, this is the same thing as the quantity of B plus C times A. We should know this from the commutative property of multiplication. We treat these like one term, so this is A times B equals B times A. But anyway, A times the quantity of B plus C, same thing as the quantity of B plus C times A, which is equal to A times B plus A times C. And looking at it from this perspective, you can see I distributed the A into the B and the A into the C, and I transferred the plus sign. A, B, and C are all terms. A term could be a number, a variable, or a product of numbers and variables. When we talk about expressions, individual terms, or term is the word we use when we talk about the number or the variable inside, or the product of number and a variable inside of an expression. So here is an example of a term. And when we look at terms, so this is a term, this is the example including a product of a number and a variable. 6 is our number, x is our variable. When we see the product of a number and a variable, in this case, the number, we call it a coefficient. And then variable, naturally, we know what a variable is by now. But again, a number multiplying a variable, that number has a special name, and we call that number the coefficient. A term that contains only a number and no variables is known as a constant. And the reason we call this a constant is because when we graph variables, the value of the variable is changing. When we graph constants, however, it doesn't change. It constantly stays at that number. So 2 is a constant. All right, so here I have an example of an expression setup, and we're going to talk about this, and then we're going to get back to our distributing, but I want to make sure we understand our vocab words well. This expression has four terms: 6, 4x, -8, and x. Those are the four terms in this expression here. Our constants are 6 and -8. These are the two numbers not being multiplied by any variables, so these are our constants. The coefficients, now, our coefficients are very simply 4 and 1. I tried to put these x's in gray here so we know where the 4 and the 1 came from, but the variable is not part of the coefficient. The only numbers we care about are 4 and 1. Now, the 4 is pretty obvious. This 4 came from the 4 in front of this x here. Where did this 1 come from? I don't see a 1 in front of the x. Very simple explanation for that. Whenever you do not see a coefficient in front of a variable, it is implied that there is only one of that variable. So there's nothing in front of this x. That means the coefficient for that x is just 1. And then the last thing I want to take a look at from this expression is our like terms, because those we can combine. So we have 4x and x. These are like terms because they both share this one x, so they can be combined. And then 6 and -8 here are also our like terms. They are just constants. We can add numbers together. We know this by now. And this u here, I'll probably get to this in another video. This means union. It's a fancy way of saying and. So these are like terms and these are like terms. So now we're going to look at ways we can simplify this expression. So first I just rewrote it here. And I wrote it, as you can see, I wrote it out two different ways that we can simplify this. The first way I did here, I grouped the like terms together. I added them, so 4x plus 1x gives us 5x's, and then 6 minus 8 gives us -2. So if we have 5x plus a -2, we don't need to say plus negative. We can very simply drop the plus, and we have 5x minus 2 as our simplified form. Then over here, I did another example we can look at where we see, well, actually what I do is I factor, which is backwards distributing, but we notice here that 4x plus x, these both share a term of x, so we can actually factor that x out because it's shared. I'm going to have another video where I go more in depth with factoring, but this is a good just little example. Again, 4x and x, they both share an x, that can be factored out. So 6 minus 8, because these are both even numbers, I know they share a 2, so the 2 can be factored out, and 6 divided by 2 is this 3 here, and then -8 divided by 2 is this -4 here. Now, these numbers, because they have no like terms to be factored out, we call these relatively prime. Relatively prime is not really a word they use much in high school, and I'm honestly kind of surprised they don't. But when two numbers are relatively prime, it means they don't share any like terms. Very simple. So after we factor out the like term, we could simplify the expression inside the parentheses. 4 plus 1 is 5. 3 minus 1 is -1. So 5 times our x, 2 times our -1, and we get the same answer we got here, 5x minus 2. So we know this all checks out. I also made an important note here. An expression is in its simplest form when it contains no like terms and no parentheses. So if you see on a test, simplify this to its simplest form, you know you're done when all the like terms are combined and you have no parentheses anywhere. You could arbitrarily put up parentheses if you want to, but that's a different story. All right, so back to distributing, because that's what this video is supposed to be about. I have an example here to work through. We're going to simplify this expression, and again, we're going to need to distribute to simplify. So the expression we're simplifying is 3 times the quantity of 2x plus 5 minus the quantity of x minus 1. So when we look at my work here, the first thing I want to point out is, and I picked this one with a minus here on purpose because this is so important. I see this mistake all the time, and I can't stress this enough. When we have a minus before a parenthesis, what we actually want to think of that as is plus and then -1 times whatever's inside those parentheses. And the reason we want to think about it like that is because it helps remind us that we actually have to distribute the negative into both of these terms. Very common mistake that I see this mistake all the time where students will take this and say, oh, let's write that error a little nicer. Students will take this and say, hey, well, this is equal to -x minus 1. Wrong. It is not equal to -x minus 1. This negative must be distributed to both the x and the -1. So we could see that what this should become after we distribute, well, let's take a look at the left side first. Distribute the 3 into the 2x plus 5. So I just rewrote it here. So that's going to be 3 times the 2x, transfer down the plus. and then 3 times the 5. Again, 3 multiplies both of the terms. So then I transferred down this plus here, and I distributed this -1 to both of them to remind myself that I have to multiply the x by a -1, and I have to multiply this -1 here also by a -1. And I rewrote this as a plus here, again, just to keep my signs clean. I know it says x -1, but like we said before, with, where was our other example? Oh, maybe we didn't say it before. Either way, a plus and a negative is the same thing as a negative, so I just wrote plus -1, again, just to help me keep track of my signs, to remind myself that we're doing this -1 multiplied by this -1, so it's going to change the sign. So we keep simplifying this. The 3 times the 2x give me a 6x here. 3 times 5 gives me a 15. And then transfer down the plus again. The -1 times x is a -1x. And then we have the -1 times the -1, +1. Keep on simplifying, and now I just group the like terms next to each other. So the 6x I transfer down. Like I said before, we typically don't say 1x, we just call it x. Since this is -1x, I'm just going to write -x, it means the same exact thing. Bring the 15 over there, the +1. And from here, I combine my like terms. 6x minus x is 5x, 15 plus 1, 16. Final answer here. All right, so I have one more example, and this one I was hoping we can go through together. So this problem reads 2x times the quantity of 6 minus 3 plus 2 times the quantity of 3x plus 2 minus the quantity of x minus 2. All right, so the first thing I'm going to do is we see in here no like terms, nothing to be combined. In here, no like terms, nothing to be combined. However, our first set of parentheses has like terms, 6 and -3. They're both constants. We can combine them. So let's start with that to make our life easy. So we could say that this is equal to I like the thicker one. There we go. This is equal to 2x times the quantity of 6 minus 3 is very simply 3 plus 2 times 3x plus 2 minus, actually, I'm going to rewrite this like I did with the other one. I'm going to call this plus and then put the -1 here again just to remind myself that, hey, this negative needs to be distributed to both the terms inside of there. And that's what I'm going to do next. I'm going to draw my arrows to remind myself how to distribute. The 2 is going to go into the 3x. The 2 is also going to go into the +2 there. And then we're going to distribute the -1 into the x as well as the -2. So let's start simplifying this. Well, this we know can be simplified over here. 2 times x times 3 is going to give us a 6x. Now we distribute the 2 into the 3x plus 2. 2 times 3x is another 6x. And then 2 times 2 is 4, so we're going to write +4 here. Now we'll move on to this part of the expression. -1 times x is going to give me a -x. And then -1 times -2 is going to give me a +2. So now we have a pretty long expression here. Something that I recommend to students when they're first working on this stuff to keep track of things, group the like terms somehow. When I was a student, I was underlining because I have this nice technology. I like to use the highlighter. So we have 6x, 6x, and -x. Those all share an x. They're like terms. We can't combine them. And then we have 4 and 2. Both constants, like terms, can be combined. So when we combine our x's, we have 6 plus 6 is 12. 12 minus 1 is 11. So we have 11x, and then 4 plus 2, 6. So this expression simplifies to 11x plus 6. So this is all I want to talk about today, the distributive property. Thank you for watching, and I hope to see you next time. Oh, and as a reminder, the notes will be in the description below. Thank you. Take care.